call is now being recorded.
Yes. Who will tell the example? Okay. So first of all, we will go through all the points of this, and then after you may recall the example related to RMI. I don't want always the answer from one or two people only. I want involvement from all you guys. So this can be done, or the application of RMI can be done by using two objects, stub and skeleton. So what is stub exactly? So it is present at the client side. So stub is an object act as a gateway for the client side. All the outgoing requests are routed through it. So whatever the request we are giving to the server, all those will be processed by your stub only, which is present at the client side, and then it will be forwarded. So it resides at the client side and represents the remote object. When the caller invokes the method on the stub object, it does the following tasks. So first of all, it initiates the connection with the remote virtual machine. As we know, RMI we are strictly doing with Java only. So that remote virtual machine is nothing but the JVM present on the second machine. That is your Java virtual machine. Then secondly, it writes and transmits the parameters to the remote virtual machine, JVM again. So it waits for the result. Then it reads. So whatever the data coming from the server side, so that will be read. So it reads the return value or the exceptions if any, and it finally returns the value to the caller. So in this way, the communication will be taken place at the client side. Then what is the task of the skeleton, which is the second object present in case of RMI? So the skeleton is an object, acts as a gateway for the server side object. All the incoming requests are routed through it again. So when the skeleton receives the incoming requests, it does the following tasks. So the first one is it reads the parameter for the remote method. Second, it invokes the method on the actual remote object. And third, it writes and transmits the result to the caller. That is nothing but your client. Okay. Okay, server client kind of application, that is okay, but uh, server client type of applications are there, which we have studied in our first unit of DIS only. But any kind of specific programs related to this, I think Adarsh has given the answer for this client server. So after looking into this particular diagram, you may get some more idea. So that is machine A is there, which is, we can call it as a caller. Then machine B, which is having the remote object. So for this application, it will be working as the server. So stub, as we know, it is present at the client side. Skeleton, it is present at the server side. And through internet, or suppose for our level, we are no, okay, internet only. That is wireless communication we are following here only. So here through internet, these two machines will be connected then. Okay. So I will give the example for this. You might have gone through this. Suppose, for example, I am sending, or you want to perform the addition operation. Okay. So whatever the numbers that you are passing, that is going through the machine number A or your client. Okay. So suppose, for example, I am sending the data 5 and 10 for the function add. So that add functions definition will be present on the machine B. Okay. So I will be sending from the machine A only the data 5 and 10. So that will be processed at the server, and the addition operation, that is 5 plus 10, 15. The answer 15 will be sent back to the machine A from machine B. So that kind of operations, not only related to addition, any other program or concatenating two strings, multiplication, such kind of applications you might have did, okay, in case of Java programming. So what is the basic idea is, for your client machine, you not you don't need to preserve the definition of the any of the functions. So this is just the primary example of addition. If your code is having a vast definition of any of the function, then you can store all these definitions on the server side. You can just call the functions from the client side, okay, and related function will be executed from the server side, and that particular data will be processed to the client. So that kind of application we are performing in case of RMI. Okay, so this is the main idea over here. Some more material related to the RMI you can search on web also, so you can get more idea over there. So I got one document which is covering the case study of RMI, Java RMI. So just outline was given here, goals of RMI, Java RMI object model, then interface definition in Java, and RMI architecture. The architecture just now we have seen, it will be the same for every anywhere. Okay, this is the simplest architecture for RMI. If you want to go in details, you can get many more other diagrams also on the net. Okay, then okay, so RMI architecture is present at the presentation layer and session layer only. So there only the implementation is done. So goals of RMI. So Java 1.0 object communication confined to objects in the one virtual machine. So RMI supports communication between different VMs, that is the virtual machines present on one, two, or many number of computers present in your network, and potentially across the network. Okay, provide tight integration with Java. So it is the best application we can say by using Java. It minimizes the changes to Java language or virtual machine. Work in homogeneous network or environment only. Homogeneous, why homogeneous? Or what we mean by homogeneous in this case? So whenever we are performing, means I personally have not tried, but whenever you are performing these kind of applications, you are mostly performing your applications on the machines which are homogeneous. Means both of the machines will be having same environment like operating system also. If you are performing your application by using what is that, Ubuntu OS, then mostly we are preferring both the machines should be on Ubuntu environment. Otherwise, if Windows, then both machines on Windows. But I or you may also not have tried on different environments. So this is the drawback, that RMI is working in homogeneous environment only, we can say. Then Java object model. So the different interfaces, remote objects, classes, attributes, operations, exceptions, inheritance are there. So the already the concept of interfaces is there. RMI, RMI registry, these kind of classes you might have gone through. So RMI does not have separate interface definition language. So predefined interface, which is called as a remote class, so that you are using for this. Then remote interface extends the remote class. Remote classes implement the remote interfaces. Okay. So if you go for the Java doc for remote, you will get all the methods related to the remote class, which you can use for your programming. Okay, so this is how the structure interface, suppose for example team extends remote, so in this way you can write your uh, code or the function which will throw remote exception. Okay, then RMI does not attributes must be represented as a set and get operations by the designer. Some examples are there. If you go for searching the examples related to RMI, then also you can, just now I have given you the example of addition. Okay, so that kind of examples you can get for um, this RMI also. This is one more architectural diagram is there with this particular document. So client server, client is having stubs, server is having skeleton, and through the RMI registry interface the communication will be done. Activation interface is there for RMI runtime registry. Okay, so this kind of diagram we can have. Then the kind of application, so in that way how the activation in case of Java is done, that type of diagram is been given over here. So this is your step, that means this is the client machine, client host. Okay, now firstly it will be sending the request for activating the connection between the client and the server. So activation, after activation here different number of functions. If we see now, we are going for performing the function execution from the server side for this application. Okay, but if your server is acting as a uh, what we can say, the person in between the client server, in as we may have it in just like our three tier architecture. Okay, so suppose for example from this server it will be diverted to one more machine, okay, on which your definition will be present. So this kind of scenario could also be there. So you are requesting your function over here, so it will be having the descriptors like what different functions are there with me or with this particular server machine. Okay, if that function is found, it will create the object on the virtual machine. Okay, so accordingly the processing will be done, calculation will be done, and the object reference will be given, and then it will be given back to the server. Okay, so in this way your process will be uh, or your request will be processed. If not, if this particular server is not having that particular functions definition, your request will be diverted to the machine which is having the data related to your function. Okay, so this part is done by your server internally. So this way the architecture is taking place. So this is how the RMI is working. So you might be getting question that write a note on RMI. Okay, so you just have to give the primary details, what is RMI and all. You can show the diagram. You can give the explanation related to functionality of RMI, and after that you can give one example. Okay, one simple example you can give over there which will explain how this particular RMI is working or the functionality is working. Okay, any doubt in this point? Okay then. I think many of the girl students are not active. Hmm? Okay. So, and the next bit, probably the last bit of this chapter, that is case study of CORBA. CORBA, for this, I think you have gone through the name. It is Common Object Request Broker Architecture. On this point also, you may be getting the questions like explain or write a note on CORBA for 4 marks or 6 marks. Okay, so we'll go for it. A specification or standard which specifies how objects communicate with each other over the network. So that is present with the Kurba. It is a middleware based architecture. The object request broker is the heart of distributed component architecture. It allows the developers to define distributed components architecture without worrying about the underlying network communications and programming languages. So, as we have seen the drawback of RMI, that is, it is working in the homogeneous environment only. Okay, so here we will try to overcome on that particular drawback. That is related to the homogeneous environment. Okay, so we want an architecture that supports a remote method invocation paradigm. Then it provides the location transparency. Why location transparency come into picture over here? Hope you remember the RMI programs. So here in that example, you are not performing your programs on local host. Okay, if you are performing the RMI operations on two different machines, so what type of data you are providing over there? The IP address of another machine, right? So here, uh, ultimately, you are giving the location of the machine or of the server while connecting. Okay, but the Corba, it gives you the location transparency. So no matter where your machine is, you will be able to connect with that. Then again, allows to add, exchange or remove the services dynamically. So dynamic method handling, that kind of advantage you are getting in with the case of Corba. Then it hides the system details from the developer. So the result is the Corba architecture. So if you want to go for all these points, you have to go for Corba architecture. Corba design goals are independence of the hardware platform, programming language, operating system, specific object request broker, and degree of object distribution. So it is open architecture with language, platform and location transparency, language neutral, interface definition language, that is IDL. Okay, so for all these advantages, we are going for Corba architecture. Then Corba works with the interfaces. The diagram related to this is given like this, means all the Corba objects are encapsulated. You know the meaning of encapsulations. Okay. Then objects are accessible through interfaces only. Okay. Then separation of interfaces and implementation enables multiple implementations for one interface. Then again, how comes it is location transparent? So for the client, doesn't matter if the object his operation on is running. So on the same processor, even in the same process, like this shown in the diagram, on the same process, in a different process, and in the different process on another process, all these three types of or all these three scenarios will be covered in case of Corba. same processor, even in the same processor but in different processes, and different processes and another different processor. Okay, in all these three environment you are getting the same results, or your functionality will be um, in process, we can say. Then your Corba architecture. So this is the architecture. We will go for each and every details of it. So ORB interface, that is present over here. So it is the mean between your client and implementation. Implementation is nothing but your server side, we can say. So ORB interface, it contains the functionality that might be required by the clients or the server. So whatever the uh, definitions present for the connection, or yeah, connection and its details will be present on this ORB interface, through which you are going to connect from your client side to the server side. Then DII interface, that is nothing but the dynamic invocation interface, which is used for dynamically invoking the CORBA objects that were not known at the implementation time. DII interface. So it is present over here. So you might be having some applications like you are requesting something from the server side, but you don't know whether it is present on the server or not. You are just giving your request. Okay, so at that time, this DII, dynamic invocation interface, what it does is it will properly guide you to give your request to the proper server. Okay, so it will be done at the runtime only. Okay, so that is why it is called as a dynamic. Then DSI, that is dynamic skeleton interface, which is present over here. As it is a skeleton, it is present kind of at server side. Dynamic skeleton interface, DSI, it helps to implement generic CORBA servants. Okay, so with which your request will be processed. Then BOA interface, that is basic object adapter, it is present over here. Okay, so it is the API used by the servers to register their object implementation. Why it is required? So suppose for example your client is fetching one particular request. Okay, and if it is dynamically processed, so its entry should be there with the server. Suppose for example, you are requesting, uh, or say for example you are having say 10 number of functions related to one particular server, and you are requesting the data for the function number 11 something. Okay, एक काहीतरी नवीनच फंक्शनची फंक्शनॅलिटी तुम्हाला आवश्यक आहे. So at that time, if you are processing all these things, or your registry is having the details of only 10 functions. Okay, so at that time, which is whatever the function that is newly added in this, its related data will again be preserved by using this BOA. Means now you will be containing the data of 11 different functions. ओके, नवीन काहीतरी रिक्वेस्ट आली तर जसं की आपण म्हणतो बफर मध्ये तुमच्या कॅशे मध्ये ती सगळी रिक्वेस्ट तुमची सेव्ह केली जाते, बरोबर आहे. सो नेक्स्ट टाइम तुम्ही जेव्हा ती सेम रिक्वेस्ट फेच कराल, you will be getting the results in less amount of time than that of the your first time request, isn't it? So in that way it will be preserved somewhere. Then interface definition language, IDL. So language independence defines the object interfaces, all these points. Then hides the underlying object implementation. Then language mappings exist for C, C++, Java, COBOL, Smalltalk, and ADA. So all supported language are included over here for CORBA. Then, as we know that CORBA is having the object request broker type of architecture. So it will be implemented by using this. So implementation of CORBA specification. So it is a middleware product. Conceptual software bus is present with the ORB of CORBA. It hides the location and implementation details about the objects. So if you want the diagram related to that particular application, it is over here. So your application middleware is present, an operating system which is having the drivers and your hardware. So these kind of parts we are showing for the object request broker architecture over here. Then two major tasks that are there for ORBs. So the first is ORB locates a remote component given its reference. Then ORB also makes sure that the called method receives the parameters over the network correctly. So what is the major task of ORB? That is, whatever the request is coming from the client, you have to establish a proper connection with that machine, and also giving the parameters properly to the requested function. So ORB also makes sure that the called method receives the parameter over the network correctly. So this process is known as marshalling. And in reverse manner, the ORB also makes sure that the calling component receives back the return value, if any, from the called method. Then this process is known as the unmarshalling. So these two definitions or related questionnaires can come for your MCQ. Okay, so what is marshalling and unmarshalling? Fine. So whenever you're sending your request from client to server, you can call it as a marshalling process. Okay. So in the format, you are giving it to the server in a proper format, and then whenever you are getting the data, you have to uncover it. That is nothing but your unmarshalling process. Then example of how the ORB works. Then here component A, it is present over here. It calls insert method and passes two parameters A and B. So from the component A, or we can say that machine, our client machine, it is calling for the function insert with arguments A and B to the ORB. Component A ORB picks up the request and realizes that insert method is defined in component B and passes the method name and parameters in binary form. That is the process of marshalling. Means here from the client side you are giving the data to the server. So the process is called as a marshalling across the network to the ORB at the node where the component B is located. Okay. So, and its reverse process will be whatever the data that is been processed from the component B, it will be given back to the component A. Okay. So at that time, it is converted into the readable format of the component A. So you can call it as a unmarshalling. So I had come across some of the difference points of this, like what is or why we can go for RMI, and the process of remoting. Remoting we can call it here as a the process of or the functionality of CORBA. So RMI inheritance is single class, multiple interface inheritance. Here also single class, multiple interface inheritance is there. Communication is done through socket programming in case of RMI. Why socket? Because you are specifically giving the IP address or some uh, uh, details related to location in case of RMI. But here in case of CORBA, or remoting, the communication is done through the channels. Then naming service, here RMI registry we are using, then mapping from named server object to the URL. Okay, so RMI registry or kind of URLs you can use here for naming purpose. Here in this case, hash table of the object will be used for the reference. Configuration, it is the system property, means the configuration is done in case of RMI by using the system property. Here it is present with the help of XML file. Then remotable, yes, remote interface is there, and here it is marshal by reference. Protocols, here JRMP, IIOP, this kind of protocols are used. Here in this case, HTTP, TCP, SOAP protocols are used. Then activation, RMI can be activated, means for activation purpose also you have to give some command. For the first time you have to start your RMI registry, start your server, and then go for sending the request from the client side. But here in case of remoting, it is a single call, singleton CAO called as. Then here format, it is having the serialization. Here in this case, it is SOAP or binary formatted. Distributed garbage collector, yes, it is present in both the cases, in case of RMI as well as remoting or CORBA, ORB. Error, error is handled by using remote exception. Here also remote exception is present. And the skeletons, so integrated within the framework. So this ORB also integrated within the framework, means it is having some kind of a framework or the particular design which it is following. Okay, so this is the difference between the two, and I think here we are ending with the chapter message passing. Okay, any doubt till now? Okay, then no problem. um, any other thing that you want to discuss with me as a CC? So here I will stop the recording of the notes. Oh, sorry.